Hey everyone, welcome. It's about 2 minutes till we get started, so just want to give you a heads up. We'll start in a couple of minutes. So I'll have you everyone in mute while we just wait for everyone to join. Hey, I see some people just rolling in, so bear with us for just a moment. We're just waiting for everybody to join, and we'll get started in maybe 1 or 2 minutes. Thanks for joining. Okay, everyone, I've got 11 o'clock. We're going to give people just another minute or two to join before we get started. Okay, so I've got 11:01. We're just going to wait another minute. Thanks for joining. If somebody could just confirm you guys can hear me okay and see my screen, maybe just drop something into the QA or the... Okay, awesome. Thank you. Appreciate it. Something. Perfect. Okay, so about one more minute and we'll be getting ready to get started. So thanks again, everyone. All right, I think it's 11:02. I think Denver time, so welcome. We've got people from quite a few different spots. So I'm going to go ahead and get started. We've got a little bit of introductory stuff to cover, and then we'll get into our Atomic Friday content. So a couple of things about the way these work. I'll go ahead and turn on my video stream here. This is recorded, so those of you who are curious, we are recording it. We did get that done. And I will post the slides when we're done, so you'll have those as well when you're all set. The other thing is this is interactive, so I would ask as we go through this, if you guys have questions or want to speak up, we really want to hear not just from me, but from you as well. So feel free to jump in. There'll be sort of natural pauses where I'll poll the audience and ask for you guys to participate. But anyway, welcome to Atomic Friday. The purpose of the Atomic Friday sessions are really technical deep dives into the Atomic Red Team project and also some various MITRE techniques. So today we're going to take a look at a technique called password filters, which is a little bit older technique, but I think it's still worth looking at, and I think you guys will still get some interesting insight from this. So, okay, let's see. Go ahead and jump in. So Mike was not able to join us today. He had something come up, but again, you can connect with either Mike or myself. Both of us work on the research team here at Red Canary at @T or M_Haggis. So shout out to Mike. He was a big help getting the content ready for this, just wasn't able to join the actual webinar. So also we have a lot of other people internally at Red Canary that contribute to our research. So anyway, it's not just us, but this is who we are. So a couple of things here, really quick overview. I've got about maybe 5 or 6 slides. I don't have a lot of slides. I really wanted it to be focused heavily on the content. And so I've got a little bit of background, some demos. We'll look at some code, and then we'll look at detection. And we'll get into discussion. Really, though, just a reminder, discussion will be along the way as you go through this. I think just as far as mechanics, bear with me one second. I think if you guys will post questions or ask to raise your hand in the interface, then I can address those questions as they come up. So I really do want it to be interactive as we go through this. And then lastly, we have some resources for you. So with that, I'm going to go ahead and dive in. This is going to be a little bit different than some of the other webinars. So again, a technical deep dive into a particular MITRE attack technique. And so I wanted to cover a little bit about the relationship between the content that MITRE produces, how Atomic Red Team fits in. And so this graphic really shows or tells the story. Atomic Red Team is about testing these techniques and about demystifying the technique. So give you a chance to understand the code behind a particular adversary technique. But we don't really control the content. So huge shout out to MITRE Attack. They've done the great work of building this catalog and taxonomy of all these different techniques. And so we really pair well with them, but we have felt that they really have ownership over attack and all of the different techniques that are described there. So we really view this as a cycle. So the idea here would be you're able to test and evaluate how well you did on the test and then improve. All of the Atomic Red Team tests are open source, and you're welcome to connect, and I'll give you some resources if you want to jump in our Slack channel or participate in the community in another way. So, okay, with that, the topic today is password filters, and this is actually a little bit older technique. I first saw this in 2014, or 2013 actually, on a blog post that Rob Fuller or Mubix did, and I'll show you some of that code, and then we'll talk a little bit about how maybe things have changed in the credential access space since that time. But let me go ahead and transition to my screen. You should still be seeing my screen. If somebody could just maybe give me a quick confirmation in the chat to let me know that you should be seeing my VM. Okay, awesome, great. Okay, so couple of things here. When we start looking at this technique, I always like to start with where that technique is described on the MITRE page. So in this situation, we're talking about password filter 1174. It falls under the tactic of credential access. It's a Windows-specific technique. A couple of things to point out, and MITRE's done a really good job of describing, when they describe a technique, they will tell you sort of, what permissions are required to execute this technique. So you can see there, this one does require administrator or system. So an adversary would have to first gain elevated privileges on your system in order to then use this method. And then secondly, I always like to point out the data sources that are described by MITRE. So they will show you, in order to observe this particular technique, you're going to want, in this situation, at least 3 sources of information. First would be DLL monitoring, and by that, you're thinking about like things that load a DLL or inject the DLL. So you'd want to see when that would happen. The second would be process monitoring, so process create events, and then also monitoring the registry. And we'll talk about why that's important in a minute. But essentially, you have to make a registry modification in order to persist with this technique. So that's like when we start looking at Atomic and we start like putting together a test for a particular technique, this is always where I start, and I'll usually read a little bit about the password filters. try and understand, how is it being used in the wild. And MITRE's done a really good job of, in the new layout, they track which groups are using it. And you could also see some detection ideas. And then these are really good resources here as well. So this was the blog post I was referencing earlier. So this is, again, from 2013. Rob Fuller wrote a really good blog about stealing passwords every time they change. So in that blog, Rob described setting up a password filter on a domain controller, and then anytime somebody changes that password, you have a hook into that chain, and you get the clear text password. I would encourage you to read these other references as well, because this Kaspersky report is really good. It describes an attacker that actually was using, or adversary that was using, the password filter for persistence. We'll look at this page in just a moment about from Microsoft, like how does this actually work? And then Joe Bialik at Microsoft in 2013, kind of in a counterpoint to Rob's article, wrote a really good, you can see just like 4 days later, he wrote a really cool way to do this in memory, and that doesn't require putting down a registry change or necessarily even putting a DLL down on disk. So pretty cool stuff. We'll talk about that in just a moment. Okay, so that's how I usually start. So, we hadn't heard of this technique as far as like, we'd heard about it a while ago, but it hadn't had a lot of attention in a long time. And so Mike and I were doing some research on things that are unsigned that load into the LSAS process. So the local security authority, essentially this process here in Windows, we started scanning some of our data and trying to find like, when does that happen, and what might be indicators that something's going on. So it really tipped us off. So again, a shout out to Mike. He drew my attention to this one, and we worked through it, and we thought it would be a good one to bring forward to you guys in the community. So that's the background, the backstory at this point. I think what I'll do is just, before I get into code, are there any questions on anything I've covered so far? Is everybody doing good? Like anything making sense? Just, as far as like what the technique is and why it's maybe interesting to us. If there's any questions, just maybe drop something in the chat and I'll unmute you if you want to ask it live, or you can chat it to me, whatever. Everybody good? Okay. Sounds like everybody's good. Awesome. Okay, so let's dive into some code, and let's take a look at a couple of things here. So this is a modification of the code that's basically very similar to what Rob posted. So in order to understand what's happening on a proof of concept code like this, the second place I'll usually start after I look at MITRE is I'll actually go to the Microsoft page and look at information about a password filter. So this is really interesting because if you look at this particular technique, it's following a developer pattern. This is not, it's not an exploit. It's not something that's unsanctioned. So Microsoft provides a way for you to hook a password change and validate that change against your own internal policy or against a set of rules. So if you read on MSDN, you can see that this is a known thing. And the interesting point here is that every time you run a password filter, you're going to get two calls. You're going to get one call to validate the password, and then the second call is going to confirm that that password has actually changed. And so when you look at the code, really at a very high level, this is the C code basically. You can see in this password filter, we really only need three functions. And I'll leave it to you to explore that on MSDN. But again, it's all documented in MITRE. So if you want to go back here, you can see like there's some good references here about how to install and register. And you can follow that link and go take a look at, how to set this up. But ultimately, we're going to need to expose or export those three functions in our code. The initialization routines, anything we want to set up for our password filter, and then the two calls. Fundamentally, you have here the password filter is going to be called first, and then you're going to have the password change notify that's going to notify you that a password was changed. So there's a couple different ways to write this code, but you can see it's really lightweight. I mean, most of the code in this situation is checking to make sure the file is present, and it's going to open a file and log the password to whatever path we provide. And then secondly, we'll have another point of entry where the password, or sorry, first call and then the second call. So in this situation, you can see we basically have a couple of arguments to get passed to us. All of these passwords are in Unicode and they're referenced, so that's something you'll want to think about. Now, we modified this. So again, a huge shout out to Rob. He posted the original POC. We modified it just to write to disk. I think in Rob's post, that original blog post, he was posting it out to HTTP server. So certainly attackers don't have to write something to disk. That may be pretty rare. But you could see you could really do anything you wanted at this point. So, okay. So that's the traditional way that you would write the code. This is a password filter source C++ code here file. Now I wanted to show another technique because a lot of people are using .NET these days. And so I wanted to show you how you could actually do this in C# if you wanted to. So if you wanted to write it another way, or you prefer .NET Tradecraft, there's a couple things you would need to do here. First of all, you're going to want to set up the structure for handling a Unicode string to match some of the patterns that are used inside of the unmanaged calls. And so that's really what lines 22 to 34 are, just setting up this Unicode string type or structure. And then I'm going to mimic those same three functions. If I collapse this down here, I have an initialize routine, a change notify, and a filter routine. Now, what I'm using in this particular piece of code is I'm using a Visual Studio package called Unmanaged Exports. Some of you may have heard of this before, but it's a really cool way to take a DLL that you've written in C# and expose the interfaces or export the functions to let you then jump into that code. And let me show you what it looks like. So if you actually go in and look at this here, let me see, I think I've got it right here. Example. So I use this PE Explorer. So a traditional unmanaged DLL, for example, is going to export the functions, and I can see them here after the DLL has been compiled. So if you notice, when you go in and you set this up in the .NET space, once we compile this particular DLL, and in this situation, I've already installed it, so I'll just show you what I've got on the system. But you can see that you can take a .NET DLL and expose some of the exact same function calls here. So there's my atomic filter somewhere. Hold on. Right here. So this is the .NET filter, and if we look at CFS, you can actually see a little bit different structure here, but you can see it's got all the .NET piece. But what's important is this unmanaged exports shims in the entry point with the same function names and calls. So it's really a powerful technique for those of you who like or prefer .NET language coding, but you want to maybe inject your DLL or code into something that is an unmanaged or traditional non-managed language. So anyway, I just thought that was interesting. I thought you'd like that. Mike and I just extended this. I mean, there's a number of things you can do here, but like with C#, it was just like 15 lines of code to hook the password change and then send it out as a DNS query. So trying to think about, things that attackers might do. Basically just base64 encode the name and then make it a subdomain in your query. Actually pretty easy. I think in this situation, I don't even think I conformed it to an actual DNS request. I just used that port. So, looking for one thing a lot of defenders will do is looking for traffic on a particular port that doesn't really match the protocol standard. So those are things you might look for, but this was just something we built. Okay, so the first phase then is you've got to set up the DLL. You've got to go ahead and compile that. And in our situation, very minimalistic code. Take the passwords, log them to a text file. Proof of concept works fine for a defender running this particular test. So the second phase then is actual installation. And that's where, again, I want to draw attention to the cool references on MITRE because they've already given us the link for how you would actually install this. So if you read through this document, the password filters need to be registered. And so that requires the change in the registry, and you can see where that's set up. System current control set, control LSA, you set up a sub key there or a key called notification packages. and then you assign a value. Now the value you're going to put into that is going to be the name of the DLL you want to load without the DLL extension, okay? So if you went back and looked at my, if you go back and do, if you looked at the name of my DLL that I've got in here, you can see that matches. So when I reboot this system and the local security authority opens, it's going to look for registered notification packages and ingest that DLL into the process. And then remember that that's really two advantages for an attacker. The first is it gives you access into a process that's running a system. And the second advantage is you're able to hook and get clear text passwords. So you can see in here, just using Process Explorer, I've got the atomic password filter already loaded into it. You can see it's an unsigned DLL. We'll talk about some detection opportunities in a moment. Okay, so I've been talking for a little bit. Does anyone have any questions? Basically, again, I'll publish this code. It's also out there. If you search GitHub for like password filter, there are tons of examples. There are also legitimate products that may be used in your organization to check passwords on a change and then notify or make some alert or log or something like that. There's tremendous risk here in handling a password in clear text. So be sure if you are using these for legitimate reasons, there is guidance on Microsoft's site about making sure you handle that properly because you're given the clear text password. So now, okay, so let me pause. Any questions at that point? I kept talking, so I'll pause for a couple seconds. Okay, nobody's raising their hand or posting questions. So I guess the next thing is we've written the code, we've registered the DLL. Let's look at the actual effects. So in this situation, I've got our .NET DLL in here, and so if you look back at the code, I've got basically three functions here we talked about. In this situation, I'm just going to log to a file called passwords.txt. So let's just check it. I've already got that file set up so you can see some of my previous password changes, but I'll demonstrate it sort of live so you can see it. Going here to logs, passwords. And here you can see, obviously there may be some other things you may want to do as a, attacker. You may want to encode or encrypt or whatever, but you can see here, every time I've changed the password, I get that text there. So let's make a change right now so you could actually see like what that would look like. User goes in to change their password. They put in their old password, which is $$W0RD. Let's just add a 789 at the end of that or something like that. So 789 exclamation point, $$W0RD, 789 exclamation point. Change it. And then let's just refresh our log file. Make sure our hook worked. We can see here 11/21 was the last time that file was edited. And if we go back and look, boom, you can see there we grabbed from the Windows password change prompt, we were able to log in and check. Now, just for my own sake, so I don't get confused when I go back like an hour and try to get into this VM, I'm going to just change it back. I have done that before. Oh, hold on. Where I set something in a live demo and then I forget what I set it to, and then I have to use Mimikatz to get my creds back. So it's always good. Let's see. All right. So we could just see, again, just to confirm that this is sitting in that process, it's reading any change, so the original change and the other change. So it's a really powerful technique. We'll talk about some detection capabilities and things like that, but like I said, it's not one to just dismiss easily without really understanding it. So, okay, so I covered basically three things here. We talked about the background, how these work. We talked about the code, and then we talked about how to install a password filter. I think one thing to observe that I don't know if I pointed out clearly is this is local passwords only right now, okay? So if I'm on a domain join system and I have a password filter and I'm changing a domain account, this particular technique doesn't pick that up. You would have to have that DLL sitting on the domain controller. There's a different path for domain password changes than a local account password change. So just something to be aware of. It may or may not have an influence on your environment, but it's kind of an interesting technique. So, all right. With that, let's switch gears. We talked about the code. We talked about the installation. Let's talk about detection. And before I do that, what are some of your ideas, or does anyone have any questions or thoughts about, like, how am I going to detect this? Any ideas or input? Again, I wanted to try and keep these as live discussions. So if there's anyone who wants to provide some input or thoughts, give you a chance to do that. Okay. All right, that's fine. So let's dive in. This is what we've yeah, there's a good one. So somebody posted a kind of a comment about, like, LSAS loading an unsigned DLL, and that's actually what Mike and I thought originally. And another person posted a comment about monitoring the registry key. Those are great, and so those are really good observations. So let's talk about it and some of the ideas for detection. So again, back to the MITRE technique, you can see that MITRE discloses to us that in order to observe this behavior, you're going to want at least those 3 points to monitor: DLL monitoring, process, and Windows registry. So we did some searches. We use a lot of Carbon Black here. A lot of our customer base does. And so Mike put together a query here where you can see in the top left corner, if the image is like a DLL or it's unsigned and it lives in system 32, like, let's go take a look. Now, in this situation, almost all of the things here, you can see some things I was spoofing, some certificate data here, but it's still picked up as unsigned. I would, of course, refer you to Matt Graber's really good work on this detection, because there are things that you can do with Win Verify Trust. We're not going to go into that in this like Atomic Friday, but maybe another one. But for the most part, it's actually a really good idea. Like somebody said, like, maybe I just go start sweeping the fleet and saying, what are the unsigned DLLs that are in System 32? And then the second question on that might be, who wrote it? So what process wrote that file to disk or dropped that in there? That may also be an indicator that something suspicious is going on. So certainly good technique there. Somebody also brought up monitoring the registry key. So awesome. So we had example of like a Carbon Black query or another tool, but if you're collecting registry modifications, remember, you don't always get the value. So it depends on the product, but like CB, for example, or Carbon Black will give us the registry changed. Some of the other products, or like OS Query, will give you the value. So you could, like, one of the things I think different defenders have done is pull the fleet, you know, like if you have like an OS Query or something, you go get the value back from that key and then look at it, stack it up and see, like, okay, 99% of my hosts have, you know, the default password filter, and these 2 over here have some unsigned DLL in their registry key, and those may be indicators that I want to go look into. It may be legitimate, but it may be something you want suspicious. So yeah, really good. I mean, there's a lot of different ways there, but primarily the 2 things would be looking for those registry key modifications if you're trying to catch it on the fly, or polling later to look for the values in your environment. And you can see here's another example. Like, this is the default SCE CLI, and this is a screenshot from Carbon Black. And then the other one, the second one, is the unsigned atomic.NET pass filter that I was loading into my system. So here's a couple of queries. Again, Mike wrote these up real quick. If the process name is LSAS and the DigSig result is unsigned, or if it's LSAS and it's mod load unsigned, then we're going to want to know about it potentially. So good stuff there. One more opportunity for detection that I'll just bring up is these are registered in auto runs. And so if you were to go out and different people have different ways of sweeping or collecting auto runs data, but you can see on my endpoint, LSA providers, not only password filters, but other components that register with LSASS would be in auto runs as well. So maybe some other way that you can catch it from that perspective. So, and you can see that, again, if you have the sysinternals tools, there's quite a bit of data in here that allows you to go in and look for those auto run settings. And I'll just pull it up here and show you. But that's the one that we were looking at here was the LSA providers. So I'd encourage you to go look at that and try and understand in your environment what is normal, what is new, what is being added in the environment. So, okay, so that's sort of the code behind, how to install it, how to possibly detect it. Now, one of the things that we love to do with Atomic Red Team is then go put that to the test. So let me just show you what an example would look like. And this is the test that Mike and I wrote. So if you're not familiar with the Atomic Red Team, we converted most of our tests to the YAML specification. So YAML 8 markup language. So the idea here is it's an easy way to describe in a text format what you should do for the test. So there's a schema that we've defined inside of our Atomic Red Team. And so here you would see like, all right, here's the technique. Here's the name of the technique, and all of those map back to Miner's catalog, and then you define the test. And so in this situation, we only have a single test, but you could actually have multiple checks if you wanted to test this in a couple different ways. But at a really high level, you give the test a name, and then you check the supported platforms. There may also be on some tests input arguments like, actually, as I look at this now, this is probably a good one. If you notice in my test on line 22, we just wrote this for the test, but there I have this hard-coded path for where the source filter is. That's a great candidate to just be a variable so that you could change that as a defender when you're running the test. So let me show you what that might look like real quick. Just go off script for just a moment and look at another test. So there's a couple of different ways. The standard that we use to describe the tests or inputs is a variable called input arguments. And then you would say file name, and you'll notice here then that whatever you want that file name to be or input argument, we can simply do a find and replace of that string later. And then, so that would be a good one. So like in this situation, if I were to do this here, I'll just go ahead and do it. It's not that hard. If you look at where it falls in the schema, name, description, supported platforms, input arguments come before the executor or the thing that runs the test. And so it should go right in here. And then we would have, okay, wait, too many spaces there, but we'll say file name, default path, maybe it's in this location here, whatever. And I can set that up here, and then I don't have to worry about this whole chain here just becomes pound file name. And then in our execution frameworks, it will replace that. So the other opportunities for changes would be variables. In this situation, like the path is pretty set. You have to change that registry key, but you get the idea. So let me take you through this code real quick. We just wrote a really quick test that's going to do PowerShell. It's going to copy the DLL that we want to use as our password filter that we've built and compiled. And then it's going to put it in system32, and then it's going to go ahead and make the registry change. Now, I added this line here because if you're changing the config on a system, I don't want you to forget what the original key was. So you don't want to like delete the default password filter. You may break the system, or if you get something in there incorrectly configured. So always good to back up your original value and then set up the replacement. So here it's really just like 3 lines of PowerShell. You could do this another way. You could easily do it with like a reg.exe or however you want to set the registry. But in this situation, like if you go back to Mike's slide, you could see actually here when he was looking at what was changing the values, a couple times I changed it manually as a part of the test, and then a couple times I changed it with PowerShell. So you can see a lot of defensive tools would pick that up. And then it would be up to you as a defender to make sure when an analyst or someone on your SOC reviews that they understand, okay, what exactly is this? So, okay, hold on one second. I had a really good question come in just a little bit ago. Let me just read it real quick, and then I'll respond here. There's a particular question that came in about a particular event ID, and that's actually really good. And so let me follow up with that question about a particular event ID that tracks that a notification package was loaded. So that's actually really good. I will put that in my follow-up notes. So thanks for bringing that to my attention. I like that. So there's a particular event log that will show you that. Really good stuff. Another question came in: is there a way to collect unsigned DLL loads with Sysmon? Let me follow up with that as well. Let me go back. Like, if you're not familiar with the Sysmon schema, like if you go in here, I don't think I have, in this particular case on my test box, I don't think I have it configured to track that information. And so let me pull that up real quick. It's good questions. It would depend on like the Sysmon configuration. So like I think in this one, I've just got the process creates and things like that, some driver configs. So let me get you guys the config. It's a good follow-up. The Sysmon config, like if you go look at their schema here, let's go back out to Sysmon. So if you look at Sysmon, it's a really good point to look at all the different components here. And so I'm trying to remember off the top of my head a good way to get the certificate data from Sysmon on mod loads. I'm probably going to have to follow up with you guys on that. But all the different event IDs, so like if you go down here to, let's see, load it, like, there you go. So here's the, it looks like it does get it. So let me follow up with you on that. It looks like there would be a way to get that out of Sysmon. Like I said, I don't really use like that on our production systems right now, but I'll definitely dive in and get you guys some feedback. So two really good questions. So the one follow-up is the event ID in Windows that tracks notification packages loaded, and then Sysmon loading, getting the signature data. So I'll follow up. Those are really good. But sometimes after these, we do like a follow-up blog post. So those are really good. Another question came in talking about different red teams signing their DLLs. And that's actually a really good point. It's really trivial to set that up. And so, yes, you may, if you're just looking for the check of signed or unsigned, that can actually really is more brittle as a detection than you might think. So that's a really good point. For example, in PowerShell, with the new version of Windows, there's a like a set authenticode signature. So I mean, you can literally just, even though it's self-signed, the different products have different ways of checking the signature and does it chain up to a trusted CA and those type of things. But I would definitely use caution. It may be a point of entry to start, but it may not be the final piece of data that convicts that asset just because of an unsigned DLL load. So that's a really good point. Or signed, just because it's signed, I think maybe to your point, doesn't necessarily mean it's okay, right? A signature is providing two things like identity and integrity, not necessarily, good or bad, if that makes sense. So I think we've certainly seen that. So let me pause there. There were three really good questions that came in about the event log, Sysmon, the signature data, and then the red teams or adversaries signing their DLLs. Any other questions that hopefully I answered those okay? And like I said, I think I can provide some more detail in a follow-up. But let me just give everyone a moment. Let me pause for a second and give everyone a chance to maybe think about that, or maybe think of other questions while we go through that. Okay. All right. So at this point, couple of things I wanted to, as we're kind of closing in on time, just a few more minutes left, 15 minutes left or so, kind of open up to general discussion or thoughts. These are my observations about this particular technique. It may not be your observations, but these were sort of the things that as I was looking at this that I thought, well, if I was an attacker or would I or would I not use this technique? So a couple of things that I put in the negative column. So first, it does require local admin rights. Second, it requires a reg mod. Third, it requires a DLL on disk in a particular location. Fourth, it is picked up by things like auto runs and tools that are searching for that registry change or modification. Fifth, it really, in this situation, only catches a local password change unless you're on a domain controller. Things, however, that are interesting to me, though, are one is the low detection rate. So from a standpoint of a tool that's just, logging passwords, I think, let me just do this real quick. I think if I go out to VirusTotal and we upload just live, I don't know, let's just try it. So let's say I go to, let's say we want to scan that DLL that I created. Now some vendors will pick up on the technique about with the unmanaged exports and flag that as malicious. But if we go in here, grab, here's one here. So this is one I compiled back in October, does the same thing. I think this is the one I actually uploaded earlier. Let's see, this one may already be out there. Yeah, there you go. So this is what I mean by low detection rate. So here's a filter, password filter, that logs password changes and nothing tagged it as malicious. So if you're strictly relying on the binary to be picked up or not picked up, there's opportunity there that attackers may leverage. So that was one of the things I thought was interesting about that technique. Second thing is it definitely is a persistence mechanism, because on reboot I get my DLL loaded into lsass with a high privilege, and then thirdly I do get my password in clear text. So I kind of came to the conclusion, I could be wrong here, but I was kind of like, well, given the landscape today, there are probably better options that may be out there, but that doesn't necessarily mean that an attacker wouldn't use this, or that I don't need to understand it. But there are certainly, in the credential access tactic, there are certainly things that there's a whole menu of things that an attacker could do. But one of the things we wanted to do is talk about it and bring it forward. And in that way, if you run into it or you're trying to test for it, hopefully we've described, at least at a very high level, all the different components. So a good question came in, and this was the observation that I made earlier. So somebody made a question that said, if you have to come in, if you have to be local admin and you're only catching, in this situation, local password changes, is it really useful? And that was the question that I was having in my mind. However, to counter that point, like, what if this got onto a system like a vendor system that had some local accounts for remote access or something? Like, there could be opportunities where this could be very valuable, like a multi-tenant situation where there are just local accounts in an organization or something. So, but yeah, in order to catch those domain passwords, it would need to be on the DC, which hopefully you've got tighter controls around your domain controllers, but not everybody does. But yeah, to the point of the question, is it really that useful? I mean, that's one of the things. Like, Mimikatz is a lot more popular, has some interesting things that you can do in memory. But again, hopefully this is still good. Hopefully you've learned something along the way as far as looking at this technique in a deep dive. So, but I don't disagree with those questions. Like, I feel like, yeah, I mean, it's probably happening or has happened, but anyway. Cool. Does that answer those questions? Any other questions or comments? Hopefully it's helpful. Again, I wanted to put this out there to create some discussion, not necessarily come forward with all the answers here. Just wanted to really think about looking at a technique like this, drawing some conclusions around detection, and is it the #1 technique I want to go after with MITRE? I think it's probably debatable. Like, I don't think so. I think there's a lot of other things happening on that matrix that would be higher than this, but at least we understand not only how to code the test, but then also, hopefully one of the objectives for these Atomic Fridays is to give you some ideas about, now that we can describe the test, we could check for it regularly and make sure our products would see it. If it did show up and somebody happened to drop and register one of these things, hopefully we've got the telemetry in place to see it. So cool. Some good feedback there. Okay. At this point, I think we're kind of closing out on time here, maybe a little bit early, but let me just open it up for any questions or additional comments. Some folks have had some really good questions and input, so again, I don't want it to just be me, but so other thoughts or feedback at this point. I'll kind of pause for a second. I need some hold music. Well, they say it takes 5 seconds to formulate a question. So as a presenter, you're supposed to just not move on. But, okay. Okay, so a question did come in about tips for how do you prioritize the techniques that come along with MITRE. So that's actually a really good question. And I don't know that I'm going to have all the answers for it right away. But you know, if you go out to this matrix and you look at this matrix, you may think like one of the questions I have is like, where do I even start? And so maybe what I would recommend is thinking about what data sources do you actually have in place today? So let me see if I can find, I think I've got a reference here. 1 second, bear with me. One of the things that I did a little while back was I went through and I looked at all of the different MITRE techniques. Let's see here. And so I'll publish this. There's no secret sauce here. This is just data sources mapped to techniques. And Roberto Rodriguez at SpecterOps and Devin Kerr with InGame did this, a really good presentation at B-Sides last year on this, very similar approach. So really just shout out to their work. But the idea here is, okay, if this is the technique and what do I need to observe? So what I would do is start with, okay, well, what am I able to observe? So for example, if I can't even observe process command line today, then you know, if I had to prioritize my list, those would not be the top things to go after because they don't have visibility. So I guess when you look at this list and you're like, where do I start? My recommendation might be, what are you collecting today? What can you observe of the data sources? And then start looking at the different techniques that you can observe. I think of particular interest, honestly, are things around execution and defense evasion. That's a little bit anecdotal because I don't have hard numbers behind it, but certainly there's a lot of opportunities here for people executing things or trying to bypass, you know, systems. Credential access would be another one. But I don't have a really good list of like, these are the top 10 things you should start. And that's a really good takeaway. I think that's the second or third time I've heard that. So let me pause there. Does that help answer that question? And somebody just posted a link that I'll reference out for everybody. It's the link to Roberto's work. Also, huge shout out to the team over at ER&W. I tweeted this out the other day, but they did a really good blog here on using the new format. And so, for example, I don't remember if I have this one loaded up already. No, let me switch into. Here's another way to analyze the MITRE attack data. So Roberto's got a good blog, spreadsheets, and then also this is one that ER&W put out. And so it's called like Invoke Attack Knowledge. And so it's really easy to get some good, let me show you here what this looks like. So it would look something like this. And so it will go out and read the various configuration files. And then if you notice now I have a couple of different functions that he's added. So like get attack technique. So if you look at this, you can do get attack technique and you can do either name or ID. So ID is a little bit easier. But if you say 1174, oh, I think it needs a T in front of it. Lots of red on the screen there. Hold on. Forgot about that. So yeah, so just do T1174. And it will go out and get like that particular technique. And then you could just do something like, you know, what are the attributes associated with that? And then what, you know, one of the attributes is data source. So I mean, there's a couple different ways to pivot, but I kind of went a little bit a long way around on that to show you like how to get to those data sources. But anyway, hopefully that's helpful. So there's another question that came in. Do we have a heat map or matrix based on what we've observed and how we could prioritize? We have some of that data internally, but I don't know that we're ready to publish it yet. So yeah, it's a really good question. I mean, so, you know, we have a lot of detection data. I mean, we have quite a bit of endpoints, and we've been monitoring for several years now. And so you can imagine there's a lot of cool stuff. We did mappings on that, but again, I'll kind of deflect on that for now. We don't have anything public yet, so it's a really good question. So, okay, let's see. Other questions or thoughts? Maybe just provide some feedback to see if it's helpful around these sessions. Again, the object here is trying to encourage you to learn about the technique as described by MITRE, understand the code behind it. I think these techniques are not a mystery. You can read the documentation, you can write your code or learn to write the code that will mimic the test, and then write a test that will allow you to look at detection coverage. So we've tried to do some of that to help the community out so that you don't have to go or necessarily know how to write something in C or C#. Certainly a good opportunity to learn if you wanted to develop or learn some of those techniques, but providing these sample binaries and code snippets are hopefully it's helpful. So I'm open to feedback on how this went. If you like these, we'll continue. You know, we have another one scheduled. Save the date for January 11th. So if you want to jump in, they're going to be really informal and just give you a chance to do a deep dive. The other thing I would put out there is I'm really interested in other people sharing. So a lot of people have done some good work in the community on execution frameworks, reporting. So if you would like to present some work on one of these Atomic Fridays, please let me know in the Slack channel. Just send me a DM. I think it would be great because I think we're not the only ones with answers here. And so we would love to get or draw attention to some of the work you guys are all doing in the community. So with that, I'm going to wrap up. There's a couple of things. Some of you may be new, but atomicredteam.io is our really good landing page we've created that talks about how to join Slack, related projects, some background information, additional resources. And with that, I think I'm going to close out. So I'll maybe pause for one more second for any last questions or insights. But otherwise, I really thank everyone for your time. Hopefully everyone has a good weekend. And yeah, that's all I got. So it's recorded. I'll post the slides and the recording later on. So, all right. Thanks, everybody. Take care.